In front of you, we have three examples of an infrared graph. And when you learn to recognize the certain shapes of infrared graphs for particular functional groups, the questions become very easy. So what I put here is just three of the typical ones you see all of the time, starting with this top one. So you'll notice that it goes down, comes back up, and then goes down again. So it sort of looks like that. And it's always between the same range, which is about 3002 to 3008. Right? When you see that, this idea of what I like to think of as a double dip, it is always the same functional group, which is an alcohol. Okay, so whenever you see this double dip, it is always an alcohol. Now, granted, sometimes it may be more extreme and it may go up like that and then come back down, but you'll always see this drop, move back up, drops again. Right, the next one, I'm going to jump to the bottom one actually, is this one. And I think this one's even easier to spot. So you'll notice that it begins all the way sort of there. So if I dot this line down, that's roughly 2,400, 2,500, all the way over to around about 3,000, 3,300, 3,400. So you'll notice that it's actually really wide or really broad. And it kind of looks like an inverted mountain. When you see this peak, so the mention of the word broad, and you've got this sort of upside down mountain, it is always a carboxylic acid. So you'll find that the alcohol and the carboxylic acid are by far the easiest functional groups to spot, just because of their distinct shape, the double dip and the inverted mountain. So finally, that leaves us this middle one, which is the bit where you have always sort of a sharp peak here. It's really sharp, it's really defined. So when I say sharp, I mean there's not much of a range. It's very narrow. As you can see, it's contained within this graph. If I just zoom in, 1650 up to around 1750. And when you see that one, it is always the double bond, the C double bond, or rather. So it's the carbonyl group. And then what you have to do is look at this part here. When you see some sort of evidence of a peak in that region, which is, if you see the 3000 there, so it's around about 2008 to 3000. This can either be an aldehyde or a ketone. So you have to be given more information in the question to make that determination. But generally, when the peak is sort of stretching quite far down, so a little bit further than that one, it tends to be an aldehyde on account of the fact that aldehydes have a C double bond O directly attached to hydrogen. So this hydrogen there, the CH bond there, is indicated by the peak sort of stretching further down. Whereas in a ketone, so a ketone group is C double bond O, and then another carbon the other side, it doesn't have that CH stretch, well, that unique CH stretch. Now sure, it could have CH stretches on the remainder of the molecule, just normal alkyl carbon hydrogen stretches, so, one there, another one there, and so on. But this one, directly attached to the C double bond O, well, it's not present in a ketone. So what you find is in that situation, if I just underline the ketone bit, it kind of terminates quite far up the graph. And then that is sort of something you can have sitting in the back of your mind thinking, right, okay, so it might be a ketone. I'm going to have to see what other clues are given to me. Have I been given some mass spectroscopy information? Have I been given some chemical test results? Maybe it doesn't react with Tollens reagent or something like that. Okay, so that is three basic graphs there. Your alcohol, your carboxylic acid, your aldehyde or ketone. And they come up over and over again, right? Now, sure, you might have the ester functional group, the amide functional group. But again, the ester functional group is going to have the C double bond O in common. It's going to have the COH, so the C single bond stretch. So these will be present in the ester group. And that is also going to be present in the alcohol as well. But again, it's this double dip that gives away the alcohol. So now let's turn our attention to just a simple example to warm up. And then after this video, you can go and watch the other 2 or 3 that I've produced on infrared question walkthroughs, which are more involved and more detailed. For the next bit, you're going to need your data table. Now, if you haven't got a data sheet with wave numbers for each of the stretches, so C double bond O, CC, single bond, and so on, I've attached sort of a mini one as a PDF below this video. So I suggest you get that now so that we can work through this question together. But if you have your own data sheet, that's fine. There tends to be not much difference between the bond stretches between data sheets. They're pretty much the same. With that said, let's take a look at this one. This question is about compound T, CXHYOZ. The infrared spectrum of T is shown. Identify the type of bond responsive for each of the peaks. Use the data book to help you. So this one, you can see immediately, right? There's a sharp peak there, which is V. And if I dot that down, so as this is an exam question, the scale is a lot more clear than the ones we just did. And you can clearly see that's around about 1600, 1620. And then 17 going up to 1750. So it's straight away, that's confirmed as a C double bond O. And then W, well, that's 1000, that's 1001, 2. So if I dot that line up, it's kind of like between 1200 to, that's really sharp. So that's maybe just 1300, just over 1300. So we're looking for a sharp peak between 1300, between 1200 and 1300. So if you look at the data sheet that I provided, the bond that matches W is actually a C single bond O. Quoted in the data sheet as being between 1000 and 1300. So what's coming to mind, as in for the functional group for this molecule? Well, without any extra information, if I was to hazard a guess, probably going to be the ester. But we don't know yet, because as you can see, this is just part of the question that I've used to demonstrate reading an infrared graph. We would need more information. And then this very short peak there, that tells me that it's not going to be an aldehyde. It could be a ketone, but we've confirmed that there's a C single bond O, so it's likely to be an ester. Next now is to look at a full-blown question where you're given other clues and you've got more involved infrared to look at. So check out the links below and watch that video next to sort of complete your understanding of this topic.